So we're going to start with the bell ringer question for today. The bell ringer question said a drama club is selling tickets to the spring musical. The auditorium holds 200 people. Tickets cost $12 at the door and $8.50 a purchase in advance. The drama club has a goal of selling at least $1,000 of tickets on Saturday's show. So we know when we hear the word systems that we're going to be dealing with two different inequalities. Knowing that, I know that I need to figure out what are the two things behind the door. The first thing, and so I'm going to put a D for tickets sold at the door. And I'll put A for tickets in. Now, I know that first I want to deal with the two different situations. The first situation is dealing with money. So we know that money goes with money goes with money. Knowing that, let me figure out which are variable. So I can see that the door is going to cost $12, while ticket purchase and are going to cost $8. So when I write this equality, I'm going to write $12 the door plus $8.50 for a dance. And I know I need to make at least $1,000. I know that my equations mean money goes with money goes with money. Now, if I want to make at least $1,000, I would have to make more than or equal to 1,000. The second one has to do with my total. And my total is that the auditorium holds. So no matter if they bought tickets at the door or bought tickets in advance, I can't have more than 200 people. My door plus my advance ticket, I only can have 2. Now, I would have to have less than or equal to, because I fully held up to 200. I could have one person in there, but I couldn't have 1,000 people in there. So I know I would have less than or equal to. Now, the next part of it is advance. What is the minimum number of tickets that must be sold at the door that the club meets to justify your answer? So I look up and I go, okay, which inequality would represent my goal? Would it be the purple one with raising at least $1,000, or that my auditorium only holds 100 people? So right away I know, okay, goal has to be that. So I'm going to read money right here. 0.5 greater than 1,000. Now they're telling me 50 tickets were sold in advance. So I know I can plug in for my A right there. So knowing that, I have 12 plus 8.5 up. Instead of A, they're telling me that 50 tickets were sold in advance. So I'm going to be plugging that in. Greater than or equal to 1,000. Then I put solve. So I have 12 plus 8.5 times ends up being 425 greater than 1,000. Now I just solved it like a two-step inequality. So I was subtract 425 on both sides. And I end up getting 12D greater than or equal to 575. The last thing I do is divide, and you end up getting E has to be greater than or equal to. E has to be greater than or equal to 47.9. 47.9. Now, I can't have 47.9 people, right? I have to figure out that they're bigger than that. Do I round up or do I round down? And so because it has to be bigger than that number, I would round up. So I would sold at the store in order to meet my goal. So this should be review. It's basically from your lesson 11, which had to do with inequalities. But they were going to be focusing on word problems. And so I'm going to take you through a few word problems. But before that, I want you to flip your paper over and put the following down. So I'm going to put a page right here. And so the phrase we're going to be working with WW. So what that means, when we're breaking down word problems, we ask ourselves the following. The first one is, what is the question? What is the question? The second one, we call it green, is, what do we know? What is the problem? The next one, how do we solve? And the last one, I'll do black, is, does, once we find the answer, does it make sense? So make sure that you're referring to each time. So I'll be using that color coding to figure out each time, how do I solve each of these equations? And so we know that, how do you solve in this? That could be substitution. It could also be graph. So we know that, how do we solve is probably going to be one of the three within this unit. So we're going to start with this question right here. It says, Jacob and Zachary go to a movie theater for their friends. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. Zachary spends a total of $27.50 for 4 bags of popcorns and 2 drinks. Write a system of equations that can be used to find the price of 1 bag of popcorn and the price of 1 drink. So we know right now we're just, what is that first part? It's just, how do we write equations? We need to know, how are we going to write in order to solve how much a bag of popcorn and a 1 drink cost. The next thing is, what do we know? We know there's 2 different situations. We know that our friend Jacob right here, we know that he got 2 bags of popcorn. And let's define our variables. Let's make equal a bag of popcorn. And let's make drink. So we know he got 2 bags of popcorn and 3 drinks for a total of $18.25. We also know that Zachary over here he spent a total of $27.50 on 4 bags of popcorn and 2 drinks. So right there we can see that all we have to do is write the equations using what we know. Now, looking at that, we're going to need to answer our next question, which says, use the equations to determine the state, the price of each popcorn and the price of a drink to the nearest cent. So we're going to have to solve for each the popcorn and the drink. So first, I need to figure out, how do we solve? And so right away, the and so because they're in standard form and there's coefficients next to our variables, we're probably going to most likely use eliminate. And so I remember that in order to do elimination, I need to make the coefficients have be the same number but different signs. So looking at the, I can see one, and so I'm pretty sure bottom one is 4. I know I use one. I don't need to do anything that second equation, so I'm just going to rewrite. The top one, though, I'm going to need to multiply the whole thing by negative in order to get that one negative 4. Now I need to get the love by multiplying to each term. So I'm going to say negative 4p minus 6 equals negative 36.5. Roll down. So here are our equations. Now, in order to eliminate, I always need to add. And so when I do this, negative 4p plus 4p eliminates. And I end up getting negative 4d equals negative 9. Then I solve for d, and so when I solve, I divide by negative 4, I get d equals 2.25. In this situation, that means that one drink costs $2.25. Does that make sense? Yeah, a drink would cost around that much. Now, if it didn't make sense or if it was negative, I would need to go check my work. Now, the final thing is I need to not only get the drink, but I also need to get the bag of popcorn. I'm going to figure out what the bag of popcorn is. All I do is I take one of the equations, doesn't matter which one, and I plug in 2.25. I'm going to use the first equation before we even did, which was plus 3 equals 18.25. But instead of, I'm going to call, I know how much it's going to cost. It costs 25. Now I'm going to solve for, when I do that, I get plus 675 equals 18.25. Now I need to subtract the constant on both sides, and I get t equals 11.5. I then divide on both sides. I get equals 5.75. That means a popcorn costs $5.75. Movie theater, does make sense. So that was our first one where we can see that we did elimination to break down a word problem. Now let's go to another one. Let's go to this inequality. So we know that an online electronics store must sell at least $2,500 worth of printers and computers per day. Each printer costs $50, and each computer costs $500. The store can ship a maximum of 15 items. On the set of axes below, graph the system of inequalities and model these constraints. Basically, what are my solutions? And so first, I need to figure out W. What's the question? Under the question asking the graph. I'm going to graph in a system of inequalities, which means there's going to be shading involved. And I'm also going to need to get it in slope-intercept form. So I know I'm going to get from standard I'm also going to be graphing, shading, and graphing. Second is that, what do we know? So what do we know? First of all, we know that the x-axis right down here is for a printer. So my x right here, I'm going to make that the number of printers. And since my y-axis here, I'm going to make my y equal to the number of. Now, I also know that a printer costs $50, while a computer costs $500. I also know that I only have a maximum of 15. The next is how do we solve? The next W, the how do we solve, to figure out our two qualities. So I know the first one is my money. So I know it's $50 per printer plus 500 per computer. And I know that I want to make at least $2,500. Now, if I want to make at least $2,500, I know that I need to be greater than or equal to $2,500. Not with money, minus money. Our second one is just talking about the computers or printers. I only have a max for my printers and my computers. I only can have up to, so I can have less than 15 of those items. Now I know I need, in order to graph, I need to go from standard form to slope-intercept form. So I'll start with, I know I'm going to set an equal one right here, actual on both sides. When I do that, I get y less than or equal to negative 1x plus 50. That's going to be my first. My second one, I need to get y by itself again. So I'm going to subtract 50x on both sides. I do that, I'm going to move it over a little bit, end up getting 500y greater than or equal to negative 50x plus 2,500. After I divide each term by 500. When I do that, this ends up crossing out. I get y is greater than or equal to, and when I reduce this fraction right here, 500, divide by 50, I end up getting negative 1 over 10. X plus, when this crosses out, I get plus 5. So I know those are going to be my two inequalities right there. Now I'm going to be graphing, and so I'm going to label by 1. I'm going to label it by 1. I'll make it a little. I know I'm labeling it by 1 because our y-intercepts are pretty small, so it will work out. So I'm going to start with 3. So I'm going to plot at 15 my y-intercept. Then I'm going down 1 over 1, down 1 over 1. Looks something like this. Now, I know, I know it's a solid line, solid because it has that line under it. So I know that this is a solid line that looks like that. Now, I'm going to shade in a little bit. I'm going to go back over here to the red one. So I can see that the y-intercept is 5, so I'm going to plot at 5. Then I go down 1 over 10. Down 1 over 10. It's going to be solid that has that line in it. I'm going to try to do this again. Then I know that I'm shading below the green. So I know right here, I'm shading below the green, but I need to shade above the red. So if I'm looking above the red, below the green, that ends up being this area right here. This area right here ends up being above this red, but below the green. So that would be my solution. If we forget how to do that, I can reverse that real quick, and I could shade below the green line with my crayon, right here, all below the green, we did before. And I can shade all above the red, all above the. So then we can see that this little Christmas camouflage going on. They're all of the solutions that could work. So however you want to get it, it's fine. I know that on iExcel, it has you just do the solution with no shading both, but either way, as long as you understand the solution. All right, last one I'm going to go over with you guys is, let's see, this one right here. And so it says a gardener A is 3 feet tall and grows at a rate of 15 inches per year, but B is 4 feet tall and grows at a rate of 10 inches per year. Now, the first thing we need to figure out is, what is the question? Where would they be the same height? We didn't know how many years would it take for them to be the same height. And so I'm going to label X is going to be the amount of years, and let Y be the height. And so let's look at tree A. Tree A is starting at 3 feet tall, but we want to make sure that they're 4 inches. We know that 3 feet, the same as when we multiply by 12, 36. We also know that B will have to do the same. So if this is 4 feet tall, and we multiply by 12, let's get 40. Our slope is what it's growing per year, right? This would be considered our y-intercept, our B, our starting value. Then it's growing at a rate. One's growing at a rate of 50 per year, and one's growing at 10 per year. Let's put these y-intercepts. My height is going to be X, 15 inches per year, plus if my tree starts out at 30. The other one's going to look, this one's going to be y equals growing at 10 inches per year. It starts off at 48. Now, in order to get when they're going to be the same, I basically substitution, right? So I'm rewriting 15x plus 30. But now, instead of y rate, I'm going to plug in what y equals. Y equals 10x plus 48. So I'm going to rewrite that right there, 10x plus 40. Now, I only need to solve for x because they're only asking how many years. So I'm going to draw my river and move it down. First, 10x. I get 40 equals 5x plus 30. Now, how do I get x by itself? I'm going to subtract 30 from both sides. I get 12 equals 5x. Last thing I have to do is divide by 5. And x ends up equaling x ends up equaling 9 to 5. 12 divided by 5, you end up getting 2. That means 0.4 years, they will be the same. Oh. That's all the notes that we went over in class. I'm going to go through the rest of them in case you guys need help. So I'm going to start with this one. So it says most farms sold a total of 165 pounds of apples and peaches. Let's make A apples. This one's another example because I go to bunch of. So I know it's 1.75 per apple plus 250 per peach. And altogether, I made $337. Second one's talking about pounds. So it's told us between the apples and the peaches, I know a total of 105 pounds. So you can either use elimination or you can also use substitution. so I'm going to be using this because it looks variable by itself. So I'm going to figure out, do I want to get A or B by itself? And when I ended up doing it, I ended up getting P by itself. So I subtracted A on both sides, get equals 165 minus A. So now every time I see a P, I'm going to plug in 165 minus in the other equation. Let's try that out. I have 1.75 A plus 2.5. Instead of P, I'm plugging that in. 165 minus equals 337. Next, I'm going to solve like a multi-step. So I'm going to multiply through each one. When I do that, I end up getting 1.75A plus 412.5 minus 2.5A equals 337.5. Then I combine my like terms. So the two terms I can combine is 1.7A, negative 2.5A. And when I do that, I end up getting negative 0.75A. Then just going plus 412.5 equals 337.5. Now I solve like a two-step equation. I subtract 412.5 on both sides. When I do that, I end up getting 0.75 equals negative 75. After I divide by negative 0.75 on both sides, and when I do that, I end up getting A equals 100. They got 100 pounds of apple. 100 pounds of apple. But they're not looking for apples. They're looking for peaches. So when we go back up to the problem, you know they're looking for peaches. So we need to plug it back in. Let's plug it back in. Right? I know that P equals 165 minus, in my A, I know I got 100. So I know my P is 5. So my answer would be 30. Notice that the answer choice 4 is 100, which is the other answer. They do this to try to trick you, so make sure you're paying attention. This next one, they're looking at a theater. So first thing I would do is go X, we're talking about adult. So X, my adult, and Y would be my child. Then it says in the theater there are 200. So between X and the Y, I can't have more 100. Then I know that an adult ticket costs $12.50. So adult $12.50 X. And then a child costs 5 plus 5 Y. And I know I want to have an overall goal. I want to have at least $1. That was great. I need to get bigger than it. All they're asking for is writing. I don't need to stop writing. Then when I scroll down, you guys can go ahead and grab that, but I'm just going to go right to the bottom. Morgan is telling 30 adults. So I know adult is going to be my X, and child, 80 child, which I was getting their goal. Explain why she's correct or incorrect. The goal, I know the goal is the money one. So I'm going to be using 12.5 X plus 6.25y is greater than or equal to 15. And so when I do that, I'm going to plug in 30 for the adult tickets and 6.5, 80 for the woman tickets. And it must be greater than or equal to 50. When I do that, I end up getting 375 plus 500 greater than or equal to 1,500. When I do that, $875 is not greater than or equal to 1,500. So the answer is no. And this is the reason. Next one is this one right here. So it says Franco Winston Bakery. Well, 3 packages of cupcakes make E equal, or let's make X equal to cupcakes. And Y brown. So, well, 3 packages of cupcakes plus package of brownies got negative. The other person got 2 packages of cupcakes and 4 packages of brownies. 4. Now, going around, but I would highly suggest that we eliminate to find where they are. But since it says graph, and see how we see that graph, I know I need to go from standard slope it. I can graph. So let's close graphs. I'm going to do this one over here. So when I get it, I need to get that by itself. Right? That's both sides. Negative y equals negative 3x plus 19. Then I divide all terms by 2. I ended getting y negative 3 over 2x plus 9.5. The other one, I have 2x plus 4y equals 4. I would subtract 2x on both sides, and I get 4y equals negative 2x plus 24. Then you're going to divide all 3 terms by 4. When I do that, I get y equals negative 1/2 x plus. So let me count 1, 4, 5. Start with the last one. My product's picked. I go down 1 over 2. Like that. Green one, I start between 9 and 10. Count it 7, 9, 10. Start about right here. And I go down 3. 1, 2, 3 over 2. Down 3. One, 2, 3 over 1, 3 over 2. So it looks something like that. To find exactly where they are, it's a little bit hard to put on the graph. So what I'm going to do is I'm going to make both these equations equal to each other. So I have negative 1.5 plus 9.5 equals negative 0.5 x plus 6. So when I do that, to draw my river, I'm going to subtract 6 on both sides. And I get negative 1.5 x equals negative 0.5 x. So when this doesn't cross it, and so when I do this right here, get negative 1.5 x plus 3.5 equals negative 0.5x. Then I would add 1.5x sides. When I do that, I end up getting 1x equals 3.5. So it ends up being my x coordinate right around 2.5. To get my y, all I have to do is plug my x in, figure out what my y is. When I do that, let's do negative 1.5 times 3.5 plus 9.5. Get y equals negative 1.5, but instead of x, my x is right there. It's 3.5. Then I do negative 1.5 times 3.5. Then I do 9.5 minus 5.25, and I get 4.5 equals y. So when my x is 3.5, my y is 4. That's my answer to that one. So the last one is on the front, it's the easiest. Or here's one more. For class picnic. So they're saying, J, juice boxes, bottle of water. So 18 juice boxes and 32 bottles of water is times 90. Then 14 juice boxes and 26 bottles of water is 15. That's all I need to do for the first one. Second one, they're saying juice cost might cost 52 cents. And they're saying the other one might cost 33 cents. Why is it not possible? So we know it's wrong. Let's both and plug in 52 cents for the juice. And let's plug in 33 cents for the water. When I end up calculating this, it ends up being $19.90 equals $19.90. So I know that one. But we know probably the second one's not going to work. So 14 times 0.52 plus 32 times 0.26. Let's see if that one equals 15 cents. And I end up putting that in my calculator. I end up getting, and although it's close, it's not. So I know that's why.